Hello there guys, and welcome back to another epic Inexorable maths video. In this video we're taking a look at solving quadratic inequalities, okay? So for instance, something like 12 plus 4x is bigger than x squared, which means when we say we want to solve one of these things, what we're doing is we are looking for the range of values of x. It doesn't have to be a specific number. It's the range of values for x for which 12 plus 4 times those values is greater than the value squared. That's what that one means, okay? You can have a diversity of different quadratic inequalities. That is one of them. We're going to solve this one, and we've also got some stuff written down on the side. These are notes. These are how do we actually go about and solve one of these things, okay? Because you might notice it's not as straightforward as the linear inequalities that we were previously doing. Those you can just rearrange, your happy days. These things, they're not so easy, okay? So let's just head straight into what we're doing. Let's go straight into this thing. What's the method for solving something like this? If you see something like this in an exam, what do? Well, the first thing you do is you rearrange to make, I've written the right-hand side, technically could be the left-hand side, doesn't actually matter what side it is, rearrange to make basically one of the sides equal to 0, okay? Or maybe I should actually say, using the inequality sign, greater than 0 or less than 0, okay? Now, here's something that's crazy, and you will not be deducted marks for this in an exam, just to be very clear. What you need to do, okay, is for this question, let's just do what the first step is, okay? So how do we get one of the sides equal to 0? There's two ways you can do it. You can either get everything on the left-hand side, or you can get everything on the right-hand side. It actually doesn't matter which way around you do it. I am going to take everything onto the left-hand side just so that we have a 0 on this side, okay? So by taking an x squared away from both sides, remember we can still use those sort of equation manipulation things, but just as an inequality, I'm going to say that 12 plus 4x minus x squared is greater than 0, okay? So all we did was we took an x squared away from both sides, okay? Now, this is the weird bit, okay? The first thing that I think we should do is rearrange the order of these things here, because I would like, remember this is a quadratic in the form ax squared plus bx plus c. I would like the ax squared part to be at the front, and then the bx to be in the middle, and the c to be on the right most side. So I'm going to simply move some things around. So this is a negative x squared, remember. So I'm going to rewrite this equation, and I'm going to say that negative x squared plus 4x plus 12 is greater than 0, okay? This and this are the same. I've just written the terms. There's 3 terms here, 1, 2, 3. I've reordered them. That's all I've done. And now, because I know, really, that it's easier to solve a quadratic if there isn't a negative sign in front of here, like I'd rather that just be a 1, not a minus 1. You see how this is minus 1x squared? I'd rather just a 1x squared. So I'm going to multiply everything by negative 1, okay? And we need to be very careful when we do that. So let's times everything by negative 1. We get positive x squared. Now this is 4x, we're going to multiply it by negative 1 and get minus 4x. And then we're going to multiply 12 by negative 1 to get negative 12. Now remember guys, when you have an inequality symbol and you multiply the equation by a negative number or divide by a negative number, this equality sign or inequality sign needs to reverse, okay? So it was bigger than, it's now less than 0 because we times by a negative number, okay? If you don't know why you do this, there is a video, it's the linear inequalities one. I do explain why this flips, okay? So now guys, what we're going to do is we've got our question in the form where we have the right-hand side is in some way related to the number 0, okay? So I've written equals 0, but it's just in some way related to the number 0, okay? Now, what we're going to do is solve the corresponding, and I've written it in capital letters and underlined it, equation. What must an equation have inside it in order for it to be an equation? an equal sign, okay? An equation is only an equation if it's got an equal sign in it. That's what the part of the word equation, equate, comes from. Things must be equated to each other. They must be, the relationship is that they are the same thing. They are equal, okay? So we're going to change this sign into an equal sign temporarily and solve it, okay? So what I'm now going to say, I'm going to sort of do a line under here. I'm going to evaluate x squared minus 4x minus 12 equals 0. Not is less than, equals. The reason why is because you'll notice the next step is to sketch the graph. You must, in all of these questions, sketch the graph. I know it's so annoying. A lot of people are like, I don't need a graph, I don't need one, it's fine. A lot of the time, if you're not sort of a visual person, you don't need to draw a graph, that's fine. But for these questions, you have to draw the graph every time because it's not clear and there's no method to work out which way round the inequalities are going to be. And you'll understand more about that in just a second, okay? You'll see what I mean. So if we sketch this, this is the x-axis, this is the y-axis, this is 0. We're going to sketch this. How do we sketch this, guys? We need to find a couple of things. 3 points specifically, or maybe it's technically 2 points. And again, you'll see what I mean in a second. The first thing, guys, is always the y-intercept. Just looking at it, pause if you need to. What's the y-intercept on this bad boy? It's going to be negative 12, isn't it? Because the y-intercept is always the c in ax squared plus bx plus c. So this is going to be negative 12. We're going to say it's about there, okay? I'll even mark it negative 12. Negative 12, okay? Good. Now, guys, to find the x-intercepts, or the roots, or the intersections on the x-axis, we need to factorize and solve this thing. Or you could use the quadratic formula, or you could use any other method that you want. Let's factorize this thing. So we need two numbers that multiply to make negative 12 and add to make negative 4. I'm going to, again, pause if you need to. I'm just looking at this. I reckon it's going to be maybe negative 6 and positive 2. That looks right to me, and that's still equal to 0, okay? So the answer, the factorized version of this, is x minus 6 times x plus 2. The reason for that is simply because this is negative 6 times 2, which is negative 12. Negative 6 plus 2 is negative 4, okay? Perfect. So this is the factorized version. Now, what does that mean, guys? That means that x is either equal to 6 or x is equal to negative 2 when y is 0, which means, guys, here is a 6, here is a negative 2, roughly speaking, of course. It is a positive graph, isn't it? Because the reason why it's a positive graph is simply because the coefficient in front of the x squared term is a positive number, and it's a 1, isn't it? And so we're just going to find the graph that goes through all of these points, which is going to look roughly, and I really do mean roughly, like that, okay? It's not a good drawing. So this is the point negative 2, 0. This is the point 6, 0. This is the point 0, negative 12, okay? Just like this, okay? This is the graph. Now this is where it's so important, and this is why we're drawing the graph. We're now going to look at this again. We're going to look at this part of the graph again. We want this. Or not the part of the graph, I suppose it is the part of the graph. We want to know when this thing is below 0. When it says below 0, it means when whatever you put in for the x's gives you a y value that is less than 0. Okay? So just looking at the graph that is not very well drawn, I know, do not offend me, do not roast me for it, it's not very well drawn. Just looking at it, guys, remember this thing here, this is the graph, y equals x squared minus 4x minus 12. That's what this graph is. So when is it less than 0? When is its value below 0? Well, guys, is this above 0 or below 0? It's above 0, right? What about here? What about here? What about here? They're all positive. What about over here? Positive or negative? Positive, 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 positive. So all of this stuff on either side is actually positive. That's not less than 0. So guys, where is it negative? It's negative here, 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 up, 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 up. It's negative the whole time, which means, guys, we're looking at this part of the graph, okay? It is the part of the graph that is below 0. Every single point on this graph, in this dip section, before we get to above the x-axis, is negative. And as per the inequality that's saying that it has to be less than 0, then yes, there we go, it's less than 0. So guys, the range of values, this is the easy bit, you just have to look at these points here. These are the values where that actually switches, because when you get smaller than -2 on the x-axis, actually this isn't true anymore. And when you get bigger than 6, it's not true anymore either, okay? Actually, on -2, it's not true either, because it must be, it must be strictly less than 0. At -2, it is 0. Same goes with the number 6. So the answer to this problem here, the actual answer that you put in your exam, ANS, we want when x is between -2 and 6. Try it if you want. Put any number between -2 and 6 in to this and this, evaluate them, and you will always get that 12 plus 4x is bigger than whatever number that you chose squared, okay? So let's say that we chose the number, well, let's just say an easy one. Let's just say 0, right? 0 is between -2 and 6. Okay, 12 plus, this is 4 times 0, so it's just 0, is bigger than 0 squared, which is 0. 12 is bigger than 0. Seems about right to me, guys. Seems about right. And again, you can try it with any number. Try it with -1, 1, 2, 3, 4, 5. You could try decimals, fractions, whatever you want. It's always going to be true within these range of values, okay? So guys, what we're going to do is we're actually going to split this video into 2 videos. We're going to have a part 2 of this bad boy of our solving quadratic inequalities. We're going to take a look at some harder examples and some examples that might not even look like they're quadratics, but they actually are, okay? So thank you guys for watching. Like and subscribe if you enjoyed the video, and I'll see you in the next one. Cheers.